Hi there, and thanks for watching. If you like the content of this video, please like and subscribe. So we are going to connect to our local SQL database. If you installed SQL Server Management Studio, it should have come with SQL Server, and notice I have the server name as in parentheses localDB / MSSQL localDB with Windows auth, and then your username is going to be whatever your Windows username is. You don't have to do anything for that, and just hit connect. This way we will not have to set up a database or anything like that. Now notice we've got database security, server objects, blah, blah, blah. The only thing you really care about is databases. If you look at it, we don't really have anything just yet. So what we're going to do is we're going to create a database that we're going to use for practice. It's going to be called Northwind. I'm going to right click on the word databases and do new database. Give it a second. Then it says database name here, and we'll put Northwind. You can put whatever you like. I really, that you won't hurt my feelings. So we're just going to do Northwind. And you should see Northwind pop up with this little black database icon to the left of it. Now, as far as data, we're going to head over to the Microsoft Northwind GitHub repo. And I'm going to go to this instantwind.sql. And inside should be a very, very, very large script that is going to be used to actually set up all the tables and the data. I'm going to download the raw file, okay, by hitting this button here and then I'm going to open it up in SQL Server Management Studio. So if you open the file, it should look something like this. There's going to be a lot of stuff that you probably do not understand just yet, and that's perfectly fine. Make sure you have Northwind in the upper left selected. In this drop down, there's like master, model, etc. You will have Northwind selected, and then we are going to execute, or you can hit F5. Right, it will do it. It says commands completed successfully, and if everything's a go, you will be able to click on this button, click on the tables and expand it, and then bam, you should see categories, customers, employees, all sorts of good stuff that we will use for this tutorial. The point of SQL is to hold data, and SQL holds data in tables. You can see them on the left here underneath the table section, and they've got this little table graphic to let you know, like, hey, this is a table. Now each table has a different theme. It contains a different variety of data. Like, for example, this table is all about employees, another one's about suppliers. All right, so each table is focused on just one genre of data. Let's right click on dbo.customers and then do select top 1000 rows. This is very convenient because SSMS gives us a lot of these shortcuts. So now we have the basics of SQL. You have at the top a query, right? And we're going to write queries ourselves. And these queries are going to basically be like, hey, SQL, I'd like this data. I'd like to know every one of our customers who lives in Florida over the age of 65. Or I would like to know all the students who are freshman year but have failed college algebra or whatever. Okay, so you have some piece of data, some question you're trying to answer, some data you're trying to get out of the database, and you write a query to get it. So in this case, we're just selecting 1,000 customers from the Northwind dbo.customers table. On the bottom is the result. This is the data that's actually in the database that matches your query. Okay, so based on your query, here you go. All right, so you can see that we've got a lot of data, and it's organized into columns and rows. The columns represent one piece of data. So for example, like company name, contact title, city, right? All of our customers are going to have different, cities and have different countries and phone numbers, right? But they're all going to have those things. Okay, so our customers will have this data. It just will be different for each customer. So each customer then is represented by a single row. So this is one customer, this is another customer, this is another customer. So each row represents an individual customer in our database. So as you can see here, we've got Alfred's Futterkiste, which is a bizarre last name, and he's from Germany. And then we've got Ana Trujillo Empedrados y Helados, which sounds very good right now. And she's from Mexico, and et cetera, et cetera. You've got all of these different people. Now, we uniquely identify a row by what's called a primary key. This is the first major concept you need to learn about SQL. Notice how we have this customer ID column. Inside is basically an identifier. So for example, ALFKI specifically is for this row. There will not be another row inside this entire table with ALFKI as its customer ID. This is by definition unique. Now you're wondering, how do you know that? Because primary keys are unique. SQL is very, very persnickety. So SQL will not let you break any of its rules. If it has a rule, then you must abide by it, or else SQL will not run your query. So if I were to try to put another customer ID in this table with ALFKI exactly like this as its customer ID, SQL will be like, nah, bro, you can't do that. Okay, so now I know that this is a unique identifier. So ALFKI always refers to this row of data. Maybe the other stuff might change, like maybe they move from Berlin to Frankfurt or something like that, but this is unique. All right, so each row is unique. Now, if we go to some of the other tables, you'll notice the same pattern. Like let's right-click on employees and select top 1,000 rows for employees. There's an employee ID. So you may have, let's say you have two employees with the same name. They're both John Smith, or maybe they're both Margaret Peacock. I don't know. Well, you can use this employee ID to uniquely identify, that Margaret Peacock that who's getting a promotion next month or whatever it happens to be. All right, so these are unique identifiers. This is unique in the whole table, meaning there's not going to be a copy of it. You might have two people with the same name. That happens in real life, but you will not get two employees with the same employee ID. Okay, that you will not get. Now, let's go back to our customers. All right, now we've got this whole big pile of data, right? So we've got all of these customers. We've got 91, okay, it looks like. They're all from different countries, and they all have different addresses, etc., etc. But let's say I want to start querying for this. All right, I want to start basically sifting through this data and get the things that I want. Well, the simplest query in SQL is to be able to select everything, which we did by right-clicking and doing select top 1000, but let's do it by hand this time. The SQL queries usually begin with the word select, and you don't have to make it capital, but it's a good idea to do it because it's much easier to read. So just a little small note, it doesn't have to be capitalized, but you will see it capitalized pretty much. And then we're going to do star from, and then the name of the table is customers. And that's our first query, select star from customers. You could write it as one line, it doesn't matter, it's fine. So if I do it like this, that's also fine. You can read this star as all or stars. I've heard some people say select star from customers. I hear other people say select all from customers. They're perfectly fine to say. After that, you can hit F5 or you can hit the execute button, and you'll notice that once you run it, it will basically go to that table and give you everything in it. Okay, so that's what it means. Select star from customers means give me everything from this table. I want it all. I want all the columns and all the rows. Okay, just show me the whole enchilada. All right, now if you don't want to get everything, let's say you only wanted certain columns from this table, like there's certain columns you would like to ignore. All right, like for example, maybe we don't really care about their phone number or their fax number, right? But there's some other things we would like. You can pick and choose which columns you'd like to see in your result. So instead of doing star, we can pick things. So for example, I can do customer ID, comma, contact name, address, city, and I don't know, country. All right. So I can select these things, and I'm going to go ahead and execute my query. And now notice that instead of getting all the different columns, I just get the columns I selected. See how that select keyword comes back? See how it makes sense? So I just want these columns, and then it will go through and say, okay, cool, I'll only give you those columns. Now, SQL, again, is persnickety. Notice how if, for example, let's say I misspell something, right? Like, let's say I fat finger this. You'll get an invalid column name or some other kind of error. So that's the cool thing about SQL is the queries have to be correct, and it's very persnickety about spelling and the order in which things go into. So you have to follow a strict order of typing things, but in a lot of ways that makes SQL easier. You're always following the same pattern. There's no real leeway with this. It's always going to be select column names from customers. Okay, so the from is always going to come after the select. Okay, it's always going to follow exactly the same pattern, and I feel that makes learning SQL actually to be quite easy. All right, so now we're able to just pick out which columns we want, and again, you can do as many or as few as you want, and then we also are able to select star from customers, which will give us everything. Let's talk more about these columns because they're very important. So we are going to right-click on orders, dbo.orders, except this time we're going to hit design so that we can look at the design of the table or the schema of the table. So you'll notice that all of the different columns in the table are on the left, and you'll notice that there's this happy little key icon here, and that lets you know, hey, order ID is the primary key of this table. That's how you know. And then you'll see the column names, customer ID, employee ID, required date, ship date, etc., etc. Now the data type here is the main focus. So in SQL, just like in regular programming languages, there's different data types, like what kind of data is stored in this column. So just like C# or Java, if you ever program in those, you'll get the hang of this pretty easily. So each column has a specific type of data it can hold. You just can't willy-nilly put data in the columns any kind of way you feel like. The schema or this design tells you like, hey, this column is of this type. So for example, order date takes date time. Freight takes money. Ship via takes an integer. Ship address takes nvarchar. Let's go through some of these and what they actually mean. All right, nvarchar you can think of as any kind of string. Okay, like names of places. It can hold letters, it can hold symbols, it can hold digits. Now, the number after the nvarchar is the maximum number of characters that this column could hold. So, for example, if you try to put in a row of data with a ship name, and the ship name has 41 characters or anything above 40, SQL will barf at you. Okay, SQL says the maximum characters of something that can be put into this category is 40 characters. So 40 characters or less for a ship name is great. 41 or above, you can't do it. All right, and so nvarchar, or we also will see varchar for strings. We also have money. I think that's pretty straightforward. Integers are whole numbers. Date time is for date and time. So we actually look at orders. I'm going to right click and do select top 1000 rows. So you'll have the date time. So like year, month, day, and then the time. Okay, so that is the format that is allowed to come in here because they are date time. Notice how freight, this is money. Okay, it looks like money, $51.30. Varchar, nvarchar. So notice how these are just basically like the name of the ship address or the city. Okay, the postal code, the country. Okay, nvarchar makes a lot of sense. All right, you have ship value. See these integers. We'll get into what these mean in a moment. But now you can see that these different columns all have different types of data. But everything in ship name is a string. Everything in freight is money. Everything in ship date is date time. Okay, so that they all have to be of that variety of data, but then after that, you can do what you want. And so you'll notice that when we go through these different tables and you hit the design, you can kind of see like, oh, okay, like these are all of what I am able to choose from, right? Now, coming from different programming languages, you will have to probably learn the differences between for example, how to go from C# to SQL, how to go from Python to SQL, etc. But the main thing to remember is varchar and nvarchar are strings. Okay, that's for names, people, places, things like that. You have int for integer. You have money. Okay, let me go back to here. You have money for money. You also have date time for dates, which is very, very useful. All right, let's look at a couple more tables, kind of get the hang of it. You also can do images. If you like to do images, although some people prefer not to put images into a database. There's text. There's actually quite a few different types of data you can put in, like small int, for example, or bit. Bit is true or false. Boolean, if you come from a programming language. So there are cheat sheets online to help you learn all the different types of data. The main ones I would learn for right now are nvarchar, int, and bit. Okay, so for example, bit will be 1 or 0. If we look at product, discontinued, see how it's 0 or 1. 0 will be false, 1 will be true. All right, so chai is not discontinued, whereas Chef Anton's gumbo mix has been discontinued because this is 1, meaning true. All right, so bit, varchar, and integer, I would commit to memory right now. Maybe you could even think about money. Money is pretty useful. All right, and then just kind of peruse through these different tables and look at the different types of data that the column holds. But remember, each column is responsible for a certain type of data. I can't put, for example, strings inside of the money column. Okay, money is expecting money. I can't put bits inside of the date time. It's expecting a date. So everything in SQL has to be in its own little respective box, neatly in its own little column. All right, so here we have a result set with all the customers, which is cool, but let's say we only want customers that are in Germany. All right, so I don't want everybody. I just want customers whose country is Germany. Well, SQL's got you handled. We can have what's called a where clause. So where will come after from. It does not come after select. So you cannot do select where from customers. That doesn't work. So it has to come after the from. Remember, SQL syntax is pretty strict, but I think that's a strength of SQL in terms of learning it because everything goes in its place. So we'll do where country, which is one of the columns, equals single quotes Germany. All right, and then we're going to run, execute. All right, there we go. As you can see, every row that is in the result set, the country is Germany. And Alfred's Futterkiste, I guess that's the company name, not a person name. I thought it was a person's name for a moment, and his last name was Feedbag. But I guess that's just the company maybe they work with horses or something. All right, so here you go. All the countries are named with Germany. And then if you'd like to narrow it down more, you can. So for example, let's say I want all of the companies that are in Germany and that are also in Berlin. All right, so we could go further and say, okay, cool, where country equals Germany and city equals Berlin. So we're going to execute this query, and there we go. Now we only get rows where the city is Berlin and the country is Germany. If it doesn't fit both of these criteria, all right, then it will not be in the result set. So and means these both have to be true. They have to check off this box and check off that box. Now, maybe we want like multiple countries, right? So like maybe we want like Germany and Mexico, all right? So we couldn't do and in this case because they only can be from one country at a time. So maybe we want countries from Germany or country equals Mexico. All right, this way, we're cool if the countries equal to Germany and we're cool if the country equals Mexico. So let's execute this query. And if you notice, we've got countries Mexico and Germany. All right, so we've got Drachenblut Delicatessen, that is an awesome name. And then we've got, at the same time, Pericles Comidas Clásicas. All right, so we've got places from Mexico and we've got places from Germany. So or allows you to pick and choose. Basically, like it's cool if it's from the first box or it's cool if it's from the second box. Now, you can have as many ands and ors as you'd like in your where clause. Don't get too trigger happy with them. It gets to be very difficult to logically figure out what SQL's looking for. But there's no rule that says you can't have like 3 ands or 4 ors or mix up the ands and ors together. That's up to you. All right, there's more we can do with this where clause, but let's mosey on over to the orders table. I'm going to right click on orders and do select top 1000 rows so we can take a look at what data we're looking at. So orders is all about, orders has got a lot going on in it, but the main thing I want to talk about is this freight column. Okay, this freight is probably how much it costs to ship this order. So they had maybe some product and they shipped it out and it cost so much money to ship, and there we go. So this is how much money it cost. Now, let's say, for example, I was trying to figure out, hey, like, I'd like to see all the orders where I spend more than $50 in freight, right? So I want to filter out anything under 50. So only 50 and above. Well, we can do that. So first off, we start with select star from orders because I want all the columns. And then we're going to do where because we're filtering out things we don't want. And here we're going to do freight. And now instead of doing like equals, you can do greater than or less than. Right? Greater than equal to or less than or equal to. So in this case, I want to do greater than or equal to 50. Okay, so where freight is greater than or equal to 50. So basically, any order where I spend $50 or more. Right? Let's execute. And there you go. Notice if you look at the freight column, all these numbers satisfy this condition. Okay, 150 is above 50, 108 is above 50, all these are above 50 or equal to 50. All right, so these are all of my orders that are above 50. We also could reverse it. Maybe I want to look at what was cheap this month. Okay, I could basically say, like, hey, what about all the freight that was less than $25? All right, so we can look at where freight is less than 25, and we can execute this query. And then you can see if you look at the freight column, there we go. All right, and you can even combine these. So for example, let's say I want to figure out, I want to get where all the freight was greater than or equal to 50. And ship country is equal to Sweden. Okay, so now we're really mixing it up. So this is the power of SQL. You can really get pinpoint. You can really like filter out exactly the information that you want to see. All right, so we've got a lot of orders from shipping to Sweden or from Sweden. And there we go. These are all the expensive ones. Okay, Berglunda, Snapköp, and they're going to all sorts of places. Eckergarten. All right, so now we can use where. Okay, so the review, you're going to put the where clause after the from. Okay, and then where the point of where is to filter out the rows that you don't want. All right, so now we've got the employees table, and let's say I want to put my data in alphabetical order. So I've got these employees. I did select star from employees, but notice the last name is not in alphabetical order, right? We got P, B, S, K, C. It's not in order. So we can do that. SQL can do that for us. We're going to do order by and then last name, all right? And then I'm going to hit execute. And now you'll notice that it's in order, B, C, D, all the way up to S, okay? So it's in alphabetical order, starting from the B's, from like A, B, all the way down to S, all right? So now it's in order. If you want to reverse this order, the default order is ascending, and then the other way you can do it is descending. So you just put D-E-S-C after the column, and then if I run it now, you'll notice that it starts with S and then goes all the way up to B. All right, so you can basically do it in whatever order you would like. Now, the cool thing is you can use order by on multiple columns. So first, let me show you something. I'm going to order by city. Okay, actually, I'm going to make that normal, right? And then you can see that there's city of Kirkland, London, Redmond, Seattle, and Tacoma. All right, these are the places where the people are from. And then if I do comma and do another column I'm going to order by, first it's going to order by the city, and then it's going to order the last names of the people. So I'm going to do city, then last name. So we're going to execute this. You can see what I mean. All right, so look at it this way. In Kirkland, there's only one person in Kirkland. That's Janet Leverling, right? So of the people in Kirkland, there's only one person. But let's look at London. Okay, that is these people right here. So we got this one, this one, this one. These, what is it, like 4 people? All right, now, of the people in London, right? So the cities are in alphabetical order, KLRST. So of London, okay, of the people in London, we have BDKS. So you see how the way it did it? So first it ordered everything by the city in alphabetical order, and then when I ordered the last name, it's like, okay, of the people in London, they are in order. And then of the people in Seattle, they are in order. All right, so you are able to fine-tune the way in which you would like your data ordered. And this is pretty useful when you're doing reports because people would like to see reports, in alphabetical order so it's easier to read. You can also do this on things that are not varchar. So these are varchar columns. You don't have to do varchar. Let's say I did order by birth date. Okay, that's a date time. All right, so we'll start with 1937 all the way up to 66, and if you'd like it to go the opposite direction, you can just use DESC, and there you go. Same thing with higher date. You also could do it with extension, which is, or you could do it with like any other kind of different column. So for example, let's go into orders. All right, select top 1000 from orders. All right, and let's say I would like to select star from orders, order by freight. Okay, which is freight is not a varchar, it's money. All right, so if we do that, it will start off with the cheapest freight, okay, and then all the way up to the more expensive freight. So now you're able to really take your data and present it in the way that you want to by using order by. All right, now let's learn the aggregate functions. So sometimes you will need to group data together to answer a question. So for example, I've got my orders table. I did select star from orders just so I could take a look and see what kind of data is in here. Let's say the company comes and asks me, hey Jonathan, what's the average cost of sending freight to France? That's a perfectly legitimate business question, and SQL can help me answer it. So inside the select statement, we're going to use the aggregate function. All right, we have an aggregate function called average, AVG. And I call it the function because it has parentheses and we're going to put something inside the parentheses. So you can think of average like a function you're giving a input, okay, like a parameter. Inside is the column we would like to average, which in this case is freight, because notice freight contains values of how much I paid that sends whatever I'm sending to that country. All right, so I'm going to select average freight from orders. Now, I would like to be for France, so I'm going to use a where clause because I want to be more specific. So where ship country, because remember the column is called ship country here, is equal to France. All right, and there we go, $55.03. Now, you'll see it says no column name here, and that is not very helpful to someone looking at the data. So what we like to do is we're going to use what's called an alias. After the average freight, I'm going to write as. I'm going to just put average underscore freight. Okay, and then do this. And now you'll see what happened. Average underscore freight is now the title of the column, and this is like much easier to understand for other people. So truth be told, you don't need the as. You could literally write it like this, and it would work exactly the same way. I'm just going to put the as in here just so you just kind of remember aliasing. All right, so again, this is called aliasing. So instead of, if I didn't have this, so let's take this out. Then I'm going to hit execute, and then see how there's no column name, and then I'm going to put it back in, and then it names the column. Oh, gotta make sure I highlight everything. All right, there we go. So that makes it a little easier to see. Now, besides average, there are other aggregate functions. I'm going to put them up in a comment above. In SQL, comments, if you want to do multi-line comments, you do /*, then //, and then you can write a comment in between them. If you're not familiar with what a comment is, like if you haven't done programming languages before, like C# or really most any one of them, then comments is basically a way of telling the computer, hey, this is not real code, I don't want you to run it. Okay, this is just notes for me or another human. So we just learned average. There's also sum, min, max, and count. All right. Now, sum does just what you tell it to do. So let's say I wanted, it's like, how much did we spend on freight sending it to, let's say, Switzerland? Okay. In SQL Server Management Studio, the cool thing is if you want to like select a query like this and run it, you can do it, but the columns will be ignored regardless. All right. So of all the orders I've sent to France, if you sum up all their freight, you get $1,368.53. Okay, that takes all the freight from Switzerland, excuse me. So select star from orders where ship country equals Switzerland. I'm just doing this to demonstrate my point. All right, so what that basically means is if I took this whole column and added all of these things up, okay, to get their sum, I would get this. And it's very nice because SQL did that in like less than a second. All right, so now we can do sum. If I want to find the maximum I'm spending on freight, like which order is the maximum one, I'm going to do this. So it will give me $232.42. All right, so we go back. I want to do order by here, order by freight. Okay, just to sort of show my point. So you'll notice that the freight that's the highest is $232.42. And this, if I put it back to max, gave me that. All right, so as you can see, it can basically look through all your data and give you the maximum. The opposite is min. This will give me the minimum freight that I spent to just Switzerland. So now we can really answer some cool business questions. Now count's a little bit different. I'm going to get rid of this alias. All right, so count, we'll just count the number of rows. Okay, we can do count, and I'm going to do star. All right, so this will count all the rows where ship country is Switzerland. Okay, so let's go through here, 18. Okay, so you're saying, well, what does that mean? All right, select all from orders where ship country equals Switzerland. Let's go ahead and look at this. Notice that there are 18 columns here. Okay, so count counts the number of rows, and if you use it with a where clause, it will tell you how many rows fit that criteria. So I did select count star from orders where ship country equals Switzerland. That was basically, the question was, how many orders are being sent to Switzerland? Well, the answer is 18. Okay, which is way better than having to do this query and counting it by hand. Okay, so again, the aggregate functions are average, sum, min, max, and count, and they're extremely useful. Now, the aggregate functions are pretty cool, but they really start to shine when we start grouping things together. And group by is probably the most difficult concept in basic SQL to understand for most people. But if you really think about it, you're just essentially grouping, taking your rows and making them into bundles. Okay, so for example, we could bundle up these orders by ship country. So for example, if I did like select all from orders, order by ship country, right? Let's say I just did this query. And you can see, like, you can think of it like, here's all the Argentina, right? That's one group. Here's all the Austria, that's another group, etc., etc. Like each country is its own group of data. All right. So if you think of it like that, I could, for example, say like bunch up all of Argentina together or bunch up all of Austria together and then do something with it. So for example, let's say I wanted to get the average freight for stuff to Argentina. All right, so we did use where before, but you can use order by in this case. So we're going to do average freight from orders group by ship country. Okay, so let's see how that goes. And there we go. So now we basically see the average. Now you'll be like, well, wait a second, Jonathan, all this shows me is the average freight. And yes, we'll need to add a few more columns to this, so let's go ahead and do that. Let's first make an alias. Let's call it average freight because I want to actually have a name for here. And then let's put the ship country first. So ship country, okay, average freight. And there we go. Okay, Finland, USA, Brazil. Let's, make this a little bit more orderly. So I'm going to do order by ship country so that it's in alphabetical order. And there we go. Now we have a nice little report. All right, so it's now, instead of just basically doing like where ship country equals Austria, where ship country equals Poland, now I've got like a nice, pretty clear report showing like in alphabetical order, here's all the countries, and then here's the average freight, okay, by country. Okay, think again, we grouped Argentina together and then averaged their freight. Then grouped Austria together, then averaged their freight. And so now group by allows us to basically group data together, and then after that, we can apply one of our aggregate functions and then get an answer to our question. So for example, this gives me the average freight, okay, to each country. And then I can even go further. Maybe I can order by ship country and then order by, or I can just order by average freight and see like who's the most expensive. This probably makes the most sense, right? So like I could see that Poland's the least expensive on average and Austria is the most expensive on average. So these sorts of things really help with answering business questions. Notice how I'm combining things too. Like I'm adding group by, I'm also doing order by. So like a lot of these things in SQL are meant to be chained together so that you can craft your query just the way you want it. All right, so now we get how to use group by. And again, group by is just basically taking your data according to how you want to group it. So group by ship country. So I'm saying, okay, go through all my rows, put all the same ship countries in their own pile. All right, and then after you do that, I want to take their average freight. All right, and then list out the ship country. Now notice if I try to do another column, like, I don't know, let's just basically say like, let's go back and see what a column is in here. Select all from orders. So let's say I wanted to pick like, I don't know, ship name. All right, let's say I add that to the select statement. So ship country, ship name, average freight. Watch what happens. All right, you'll get an error saying column orders.ship name is invalid in the select list. Okay, the reason being is that if it appears in your select list, it has to also be in your group by clause. So I'm grouping by ship country, all right? So that means that ship country can be here. I'm aggregating the freight, so that's fine. I'm doing an aggregate function on one of the columns, but if I want to select a single column, I can't do that unless it's in the group by area. So if we're grouping by ship country, then ship country can appear in the select statement, but other columns cannot, unless I'm aggregating them. So I'm aggregating freight, which makes sense. I'm bundling up each country and then taking its average freight. That makes sense. Yeah, but bundling something up and then getting a single column, well, that column could be maybe 5 or 6 different things. How does it show it grouped up together in a single row? SQL's like, no, I can't do that. You're going to have to put that into group by statement. Now, group by can be filtered down just like a where clause, but instead of doing where, if we want to filter out which group, so what we can do is we can do a having clause. So after group by, I'm going to put having. All right, so let's say, for example, I wanted to get all of the freight that was above 50. Like if the average freight was below 50, I just didn't care. So I could do average freight, okay, is above or equal to 50. Then I'm going to run it, and bam, there we go. So notice how it starts off at 52 and goes up to 184. If I take off this having and go back to our original, notice that it has, Portugal all the way over to Poland. But when I put this having back in, okay, then I filter out, okay, all the ones with the averages that I don't want. So like, for example, maybe our company wants to figure out what the most expensive ones are. We don't want to know, like we don't really care if it's below 50, right? So having is a way for you to filter with group by. So group by and having are kind of married, all right? They're like hand in hand, they work together, all right? So where will not work with group by, having is with group by. Having is basically you'll have like essentially some condition that they meet, right, that you want to be able to like filter out. So for example, in this case, I only care about countries with an average freight of above 50. All right, so now we can also do something called a subquery, which is basically a query within a query. So for example, let's say I had, again, we're working with the orders table, and I select the ship name, the ship address, and the ship city, and that's all well and good. We just select those 3 columns. But let's say I want to get this information about the order with the maximum freight. So somewhere in this table, there is an order that it has the maximum freight. Okay, we're spending the most money on it. But I don't know what that order is. Okay, and that order could change from day to day. Like maybe tomorrow there's a new order that comes in, and that order is the most expensive. All right, so what I'm going to do is I'd like to really query for the max freight. So like if I wrote a separate query, select max freight from orders, I would be able to get it, right? I would do this and it would tell me that it's $1,007.64. Okay, I don't know any other information about this order, but I do know that the maximum freight in my table is $1,007.64. All right, so if I want to also get this other stuff, what I could do is I could basically have this be a subquery. And here's how that looks like. I'm going to do a where clause, where, okay, freight equals Okay, so I'm looking for an order where the freight equals this. Whatever this gives me back, I want to take that number and then use it in the above query. So what I'm going to do is I'm going to take this query and I'm going to put parentheses here and put that query inside. Okay, and make it look a little bit better. So now what I'm telling the computer is, hey, I want to run this outside query, but in order to do that, I need this other query to give me back a value. So this has to be a query in and of itself. So that's the first thing about subqueries. The subquery has to be a query in and of itself. So if I were to run this query all by its lonesome, it does, give me back a value. It works. Okay, it's a valid query. So what this is basically saying is that, hey, take this query and give me back a value. Cool, the computer will be like, okay, it's $1,007.64. So now, when we run the outside query, it will be as if SQL just erased this and put $1,007.64. Okay, so we'll take that value from the query and put it in here and then run the query on the outside. So now, I can get the ship name, the ship address, and the ship city of an order that has the maximum freight. I'm going to execute this, and we can see it's quick stop on Taucherstraße and Kunevade. So there we go, right? Now we were able to use this subquery to give us back a value, and then we took that value and used it in the outside query, the parent query. So like, that's kind of cool because now because you might think, well, Jonathan, just go through the table and find the maximum freight and put it in there. But what that could change from day to day. Orders could be coming in and out of this database all the time. I would just like to be absolutely certain I'm getting the correct order. So instead of sifting through thousands upon thousands of rows of data, I instead can query for the specific value I want, take that value and use it in another query. So again, in a subquery, the subquery itself has to be a standalone query. What that means is if I run this query all by itself, notice I'm highlighting it and then doing execute. By itself, it is a valid query. It returns a value. Okay, it returns one row. All right, and then what the computer does, it takes this value and puts it in here and then runs the whole query. So it's like replacing this whole thing with an actual value, $1,007.64. Okay, it's like basically it's replacing it and then running it. Right? If this returns more than one row, this will break, and if this is not a query in and of itself, it will break. So for example, if I just said select star from orders, well, there's a lot of rows here, right? So this doesn't make any sense. So you're going to get this error message, all right? So you got to keep that in mind, right? That this should be its own query to return a row in this case, and that will be used for freight because freight needs to equal a single value. And then after it does that, it will run the query on the outside, and then I will be able to get the information that I am looking for. So this will be the order with the most freight. And so it doesn't matter if tomorrow that's something else takes the crown from this. I will be always able to get the data no matter what state the data is in. All right, time for every SQL developer's worst nightmare: joins. Joins are actually not that difficult, except that they become difficult when the data gets to be complicated. So a lot of times with SQL, it's really not the SQL query that's difficult, it's understanding the data in the tables and how they relate to one another is difficult. So joins are all about bringing tables together. That's really all it boils down to. So I did select all from orders and select all from employees. Now if you run them consecutively like this, so if I did just type them both and hit execute, you'll have two panes. The first pane is for the orders, and the second window you see here is for employees. I just did that so you can see them side by side, so it'll make it easier for me to demonstrate my point. Now, these two tables are related to one another. How? In the orders table, we have an employee ID column. This column contains integers, like 5 and 4 and 3. What that means is that this employee ID column, is pointing towards the employees table. That means that when this 5 here is referring to number 5 in the employees table. So this 5 that you see in the orders table up here refers to Stephen Buchanan. All right, and the reason we do this is because that way I don't have to have all of Stephen Buchanan's information inside the orders table. The orders table doesn't care about who Stephen Buchanan is. Like, the orders table only cares about, the orders, the dates of the orders, which country they're shipping to. The orders table doesn't really care that Stephen Buchanan is in London and that his postal code is SW1HJR or whatever. like that stuff has nothing to do with the orders. So we store all that in the employees table, but we still need some way to know that, hey, the employee who's responsible for this order is an employee from this other table. Well, we use this number to indicate that. So this order number 10248 is or employee number 5 is responsible. Employee number 5 is Stephen Buchanan. Here, order number 10249 is responsible by employee number 6, who happens to be Michael Suyama. Right, so as you can see, this numbers references the primary key of another table. Okay, these are called foreign keys. Why are they called foreign? Because they reference another table, a table outside of this one. The table is foreign. All right, so there you go. Now, that is the first thing you have to remember, is that these numbers are pointing to the primary key of another table. Now, the naming convention makes it easy to understand this because it says employee ID. Well, there's an employees table, and that employees table has a primary key of employee ID, so that the linkage between them is pretty obvious. Sometimes the naming isn't always so obvious. It's to figure out like which one's related to. So, for example, like ship via. Ship via, well, there's no ship via table here. Okay, you'd have to know that it meant shippers. Okay, so it's ship via is referring to one of these 3 shipping companies. So if you notice that we have 1, 2, 3 here, and then ship via, you have 1, 2, 3, that refers to that other table. So the naming convention isn't always going to be of help to figure out how the tables are related to one another, but it usually is. Another way you can notice about foreign keys is if I go into orders over here and expand it and look at keys, notice it says PK orders, right? And then it has FK, foreign key, and it will say customers, employees, and shippers. Well, I have an employee ID column, which points to the employees table. I also have a customer ID column, which points to the customers table. And then I have a ship via column, which points to the shippers table. So the foreign keys, SQL Server Management Studio, you can just basically look to see what foreign keys does a table actually have. Okay, so again, the whole point of this is basically I don't want all my data to be like, you know, in one gigantic table. I'm breaking up into different tables and having one table point to another table in order for the data, for you to reference the data. Because the orders table does not care that Stephen Buchanan is a sales manager or that he lives on 14 Garrett Hill. The orders table's only, you know, mission in life is to have information regarding the order. For example, where it's going, which employee is responsible for the order, how much is freight, that sort of thing. Okay, but these foreign key references are great because I can basically say, okay, cool, employee number 5 is responsible. If you'd like to know more about employee number 5, well, then go to the other table and look up employee number 5. This is where joins come in, because sometimes you might want to say, okay, cool, we just have this foreign key, this single integer, could be a string, could be an integer, whatever we want, and we say, okay, cool, great. If you want more information, go to that other table. Now, the drawback of keeping my data separated like this is that maybe I actually do need the data from the other table to be more directly visible. So, for example, let's say there was a problem with order number 10248, and someone calls in and says, hey, who is the employee responsible for 10248? I need to talk with them immediately because, I don't know, there's some like shipping problem, right? Well, they'll look and say, okay, it's employee ID number 5, but that's not a name, right? We don't know if that employee is an employee that has like the right title or who they are, right? It just is employee number 5. So what we really would like to do is we'd like to have some sort of like new table that was like a combination of both of these. So like it had orders and had employee data like all together. So what it would be really cool is that we could ask SQL like, hey, go through all of the employee IDs in the orders table and say, okay, cool, this is employee number 5, and grab the information from employee number 5 and write it alongside everything else here. And then do the same for number 6, and number 4, and number 3. So it will go to number 3, grab Janet Leverling, and put all of Janet Leverling's information in the same row alongside everything else. Well, SQL can do that. Let's make SQL do it. So we're going to select all from orders, and then after the from statement, we're going to do join. And I'm going to say, okay, cool, I want to bring in my employees table, so we're going to join employees on. All right, now, the key thing here is how do we want to join them? Like, what column do they share that we can combine them. So remember I was just saying, like, wouldn't it be great if SQL could go find employee ID number 5, go grab this row and put it inside this row alongside with everything else? So the employee ID is the column that these two tables share, so I'm going to join on that. So I'm going to join on employees.employee ID equals orders.employee ID. Employee ID. Now this dot notation may be new to you, but all it basically means is that this is the table and this is the column. So after I did the employees dot, you'll notice that the SQL Server Management Studio IntelliSense, gave me a bunch of options. Okay, and employee ID was one of them. All right. Now I'm going to select all from orders, join employees on employees.employee ID equals orders.employee ID. So it'll basically say, cool, this is 5, go find the thing that matches it, which is this number 5. Grab this information, put it up here. Once you see it in all of its glory, you will see what's going on. All right, now on the left side, it just looks like the orders table here. You just see all the ship date, but scroll over. And look what happened. Look, you have employee ID, last name, first name, title, all of this other stuff on the right came from the other table, the employees table. And look at that, it's matched up. So this says 5 here, and this says 5 over here. They match up. That's what this is doing, okay? It's matching the two up. It's basically saying, hey, if they match up, put them side by side next to each other. And so now we know that order number 10248 was handled by Stephen Buchanan, who was a sales manager. Okay, so this is a lot more convenient for answering our question about hey, who was responsible for this order, right? Employee ID number 5 all by its lonesome was not enough to answer that question. I joined, and this brought all the data from the other table in. Now, maybe this is too big. I don't actually need all this stuff. There's a lot of columns here, as you can see, and maybe it's just too much for me. All right. Also, I kind of don't like to do all this typing. I'm a lazy programmer, and the word orders and employees is just too big for me. I'm going to use aliasing. I could put as O and just do a little small letter, or I can just do O. I'm an extremely lazy programmer, so I'm just going to do O and E. So now I'm going to shorten this and do E.employee ID and O.employee ID. So this E stands for employees and O stands for orders because of the aliasing. And now in my select statement, I don't need every single column from every single thing. I don't want that. So really what I just want to know is what was the order date? Well, that comes from the orders table, so it's O.order date. And maybe the ship date, O.shipped date. Cool, I got the ship date. And maybe the freight, O.freight. Now, if it only exists in one of, I'll show you in a second, but if this only exists in one of the tables, then you can just leave it as is, but it's good form to say, okay, cool, this freight column is in the orders table, so O.freight, and then we can bring the employee's first name, E.first name, E.last name, and maybe E. his, where is it, his title, not title occurs, it's just title. All right, so now I'm basically selecting the order date, the ship date, and the freight from the orders table, and the first name, last name, and title from the employees table. Well, now this looks a lot more manageable. Okay, so we have the order, which was shipped then, whatever this, and then the freight, and then the name, and then the title. So now I don't have to have all that data. So all joins really are doing is just basically taking two tables and sandwiching them together. All right, that is the core of what you're doing. It sounds so much more complicated than it actually is. And so if you bring the two tables together, all you have to do is basically say what condition do you join them on. The easiest way to think about it is what do these two tables have in common? So if I go back to orders and employees, select all from orders and select all from employees. The key thing to remember is just ask yourself, what do these two tables have in common? The thing they have in common is employee ID. Okay. Now remember, the naming in your job might be different. Okay, I cannot guarantee that they name things to where it would be this obvious, but the orders has an employee ID which points to the employees table where they have the employee ID. That foreign key kind of gives you a signal that this is what I'm going to join on. I'm going to join on E.employee ID, where this the employee table.employee ID equals the order.employee ID. So it's going to be okay, cool. When I bring these two together, I'm going to look at this ID. Okay, this ID says 5. Go grab 5 from here. This says 6. Go grab 6 from here. right? And that's a basic join. From there, you can do whatever you want. You can do you can have where clauses, you can have order by, you can do any of the stuff that we previously learned, and then you could bring in information from other tables. That way, you can have all the information together in one presentation based on whatever your business needs. So using other people's tables is fine, and pretty much in your job you're going to be working with tables that already exist with data that's already in there. But what if you want to make your own table? So we're going to learn the syntax. So as you might guess, it's create table, and then let's do the name of the table. I don't know, let's do Pokemon, because that's the first thing that came to mind. So we're going to have a Pokemon table filled with information about Pokemon characters. All right, then you're going to do parentheses, and then inside we're going to actually do the name of the column and then the data type of the column. So for example, we're going to do int, we're going to do Pokemon ID, and then which is an integer. And then maybe we can do like name. We'll do varchar, because remember varchar is for strings, and we'll limit the character name to, I don't know, 20 characters. I have no idea how long Pokemon names get, but they can't be too long. All right, so cool, we got an ID, a name, maybe like their power, which is like varchar, I don't know, 50, like a description of their power, and then maybe like their speed, which could be an integer, maybe, all right? And then we could do whether or not they are evolved, like is evolved, which we'll do with like a bit, all right? So I know very little about Pokemon, as you could tell, but let's just say that this was our table, and then we wanted to have our columns thus, all right? So you basically do create table and the name of the table, then you name each column, and then after the column name, you tell what type of data it is. So again, there's int, varchar, money, bit, date time. There's a whole bunch. You could look up which data type would work best for your column. Now, as far as primary keys are concerned, we need to actually tell the computer like which one of these columns is going to be the primary key for this table. To do that, after the column, which is going to be our primary key, which will be Pokemon ID, I'm going to put identity, parentheses 1, 1, and then primary key, right? Because that's going to basically let the computer know, like, hey, this is going to be the primary key for this table. So let's go ahead and execute this. Right, command successful. Now, you don't see it pop up immediately, so I'm going to go over to Northwind and I'm going to refresh with the refresh button, and then go back into tables, and so therefore we should be able to see Pokemon. So remember, you do have to like refresh the tables in order to see it after you create the table. So if I right click on it, select top 1000 rows, notice it's got Pokemon ID, name, power, speed is evolved, and if I go into the keys, I should see the primary key, PK, Pokemon, all right? So I can even look at the columns, and we should be able to see all the different columns, varchar 20, varchar 50, speed, is evolved, bit, and primary key int not null, which is pretty cool. Now the next thing you may be asking is how do we get data into said table? All right, no problem. It is insert into, all right, two separate words, and then the table you would like to insert data into, and then we're going to do parentheses. Now, you get to say which columns you want to insert data into. So, for example, I want to insert data into name, power, speed, and is evolved. I'm not going to insert an ID. I'm going to let SQL take care of that. I'm going to show you why in a second. So, I'm going to do name, power, speed, and is evolved. And notice how that the SQL Server Management Studio's IntelliSense helped me out with that. Now, after that, I'm going to do values. So essentially, the first thing you do is say, which columns do you want to insert data into? And then you say, okay, cool. In the same order, what's the actual data? So let's do like Pichu. I'm using a single quote because it's a varchar. And then the power is being pathetic, I guess, because Pichu is not very great. And speed is 5, and is evolved is 0, because remember, it's a bit. All right, and so we're going to run this, and I'm going to execute, and it'll say one row affected, and I'm going to go ahead and do select star from Pokemon, just to kind of show you that the data got in there. Bam, there it is. Pichu is pathetic. Now, if I want to insert another one, now notice how it came with a Pokemon ID of 1, right? This is the primary key, and I didn't actually set that in the insert statement. Now watch what happens if I do another one. Let's do Charizard, however that's spelled. Charizard, his power is flames. And I don't know how fast a Charizard is. Maybe it's evolved, maybe it isn't. All right, I'm going to insert into that. Cool, it worked. And now Charizard's in here, but his Pokemon ID is 2. I didn't put that in the insert into. The reason I don't have to do that is up here, when I declared it, the identity and the primary key, I basically set it to auto increment, right? So the term is auto increment. Okay, we're doing a single line quote with 2 dashes, but auto increment, all right? So the idea of auto increment is that when a new row is inserted into the table, that the primary key gets adjusted by 1. All right, the last 2 things are to delete things and update them. Pretty simple. Delete's very simple. So let's look at my Pokemon. So select all from Pokemon. And I've got Charizard and Pichu. If I want to get rid of Pichu, all I got to do is delete from Pokemon where Pokemon ID is equal to 2. Now, it's very important that you have this where clause to directly target the thing you want to delete, because delete is extremely, extremely dangerous. All right, you really want to make certain that you are deleting a specific thing, and the best way to do that is by its primary key. So now that I did this delete, notice that there is no more Pichu. It's gone forever. Pichu went straight to oblivion. All right, that is why delete is so dangerous, because if I just did delete from Pokemon, and I go back and select, oh no, there's no data in here. All right, so that's why that where clause is very important. In fact, my own personal strategy I use is always to write the where clause first and do delete from above it. That way I don't accidentally delete the thing. Because like I said, delete can be very, very dangerous. All right, I'm gonna put Pichu back in, but let's say, for example, after I put Pichu back in, I would like to change something about that row. Very simple. You can do update Pokemon, set, let's say Pichu's power is going to be zapping things, all right, and then where Pokemon ID, and let's go look for what Pichu's Pokemon ID would be. I think it's 3. Okay, where Pokemon ID equals 3. All right, so update the table, set the column equal to whatever new data you want. So right now his power is being pathetic, but if I update him, and then go back and select, you'll notice that it's zapping things now. So update allows you to take a row that already exists and to change data within it. An update should also have a where clause, not because you necessarily have to, but because it's much safer. If, for example, I had multiple things, like let's go back to having Charizard, okay, in here, right? And I select all from Pokemon, I do update set power to zapping things without a where clause, then what could happen is I will affect every single row inside the table, and you might not want to do that. So delete and update, I always remind people to put the where clause in and make certain you have it, and then do the rest of it. It sounds backwards, but a lot of bad things can happen if you do an update or a delete without a where clause. Okay, I'm harping on this because I've been there. All right, that's the basics of SQL. You should be able to go out into the world and get some data going and be dangerous, all right? So if you enjoyed this video, please think about subscribing to my Patreon. All right, I'm starting a Patreon, and I'll ask people what topics they would like me to talk about or to teach on. I can teach on a wide variety of things. All right, SQL's one of them. Maybe there's a specific SQL topic you'd like me to talk on. If you'd like that, then please, by all means, join my Patreon. Also, remember to like and subscribe. Hi there, and thanks for watching. If you like the content of this video, please like and subscribe.